Good evening, everybody. Am I audible?
Yes.
Perfect. So last hour of the day, so I'm not gonna bore you with some technical stuff. So I'll try to keep it as short as possible. But yeah, I'll keep some room available at the end of the session for some questions or some feedback that you might have. Because I mean, being part of the community is all just talking with you guys, understanding what customer is doing and how we can help the customers. Having said that, topic for today is about how do we implement CloudOps in serverless applications. And before that, a brief introduction about myself or where do I belong from. So I am a cloud consultant working with one of the partners in Stockholm. And I have been serving a couple of SMB and startups in the Nordics region, mostly on the container side, and also I do some sort of an well-architected framework review for them. So that's basically my daytime job. And apart from that also, I am part of two external cohorts of AWS. So one is community builder and one is the AWS ambassador. So the main primary objective of these cohorts is to reach out to different people or different sects of the IT sector in the Nordics region, understand their pain points, and then take it back and see if we can help them in some other way, or basically do all sort of meetups and everything. Moving on to my next one. So what will be the agenda for today? So I have divided it into three parts. So first we'll talk a little bit about what observability is and how does the CloudOps resolves. And then I'm gonna show you a demo. I promise it won't be too much long because I have already spin up everything in AWS, but yes, I'm gonna show you some console stuff, some boilerplate stuff, and then in the end I'm gonna show you what is the cost of those and what are the solution designs that are revolved around this implementation. So moving on to the first part, or what observability is. So it normally denotes three main signals. And many of us who have been working in the industry can resonate to these ones. So one of the main signal is metrics, and metrics is something that you basically use to detect how the system is performing. So if you have an EC2 instance, have you under-provisioned it or have you over-provisioned it? If you have like a serverless Lambda applications, how much is the memory consumption is happening? Or for example, if it's an S3 bucket or something. So all sort of metrics that you basically evolved and that helps you to improve your system falls under this signal. And the second one is logs. Logs is quite familiar to us, and that basically helps us to diagnose a part of a snippet or a part of a program to see if it's functioning as we intend it to, or for example, how does the system behaves, or if sometimes the system fails, you check these logs to diagnose the problems. And the last one has been coming up quite a lot in the last 10-15 years because of this shift from monolithic applications to the microservices. But the third signal is nothing but tracing. So how do you communicate between two microservices, or how do you see the trade-offs that happen when you do the modernization or shifting from monolith applications? So when I'm calling a third-party system, am I calling it on an apt way? Should I, if the mean time to return is too long, should I make it an async one? So those sort of decisions, those sort of trade-offs that you derive using this third signal. But whole of these three signals basically encapsulates what we call observability. And just to give you an example, on the left side of my screen, I have a sample dashboard from Datadog, where you can see like it has all the three signals in a single pane of glass, and it contains all the different things. So it has metrics coming up, it has traces coming up, and it also has logs. And that's like one of the example of how normally systems are set up in enterprise-based applications. So you don't need to traverse through multiple systems. You don't need to have like more custom reports. So if you have a system which has this sort of capabilities or the way to handle three signals, you can have a single pane of glass or much more tailored dashboards to check these three things and make a business decisions. Now moving on to AWS. So how does AWS helps us in this. So there are like three main facets when it comes to the observability forum. So the first is AWS has its own managed services. So it has CloudWatch, it has something called RAM. So like you can check the observability, you can check the metrics or the behavior on those. And then you have some open source or some managed services as well, like Prometheus. Then you have something called OpenSearch. And then in the last or the bottom corner is something that I'm going to focus on today, is how do you instrument your system? How do you make your system aware of adopting these things? So that's going to be our topic for today. We are not going to focus too much on how do you make your dashboards on the CloudWatch side, or how do you basically spin up or use any third-party platform. So our focus for today is basically going around the boilerplates, trying to understand like what are the single framework that can be utilized here to ship out these three signals out of the system. And to showcase that, we have one of the players that we have been coming up and we have been seeing in the customer's ecosystem. It can be small ones, it can be bigger ones, and that is nothing but OpenTelemetry. So OpenTelemetry, before going into the OpenTelemetry or what are the frameworks or what are the advanced concepts, just to showcase to you that it's basically a juxtaposition of two other frameworks or two other community-driven framework that was coming up. So OpenCensus was basically being developed to make your matrix, ship out the matrix in a vendor agnostic or in a SaaS agnostic way. And then we had OpenTracing, similarly shipping out the tracing without using any SDKs of any other third-party vendors. But I guess 3 or 4 years ago, both of these communities merged. They started coming up with a single framework called OpenTelemetry. And the reason for me presenting this is because I have a data backed up with that. And that is in the last Gartner chart or Gartner statistics that they resolved. So after Kubernetes, OpenTelemetry is like the second in one where they have shipped out, or they have more GitHub reviews, PR check-ins. So it's a quite intensive framework that is being established right now by the community or the developers across the world to make sure you have the signals shipped out in a vendor agnostic or in a system agnostic way. Now moving on to some more advantages, or why I am trying to say this is like, the first thing is like you have a single way of capturing data. So for example, even now the customer that I am working with, so they're using Helm chart of Loki to ship out their logs. They use Helm chart of Prometheus to ship out their metrics. But how does OpenTelemetry resolves your use case here? So it takes up shipping out or starting all these third-party, like different sort of resources into your application. You don't need to have so many different CRDs or sort of SDKs or whatever. So you adopt one framework, and that gives you the support of shipping out everything. And then one of the second thing is it has more data control. So if you either use EC2 based, or either you use a container based, or either you use a serverless based application. So whatever your solution that is being built, so you can make sure that the way that you're shipping out your data, either it can be in batch, or it can be either in a different way, or what would be the back end of these data. It can be a Prometheus one, it can be a Datadog one, it can be a Jaeger one. So you have one YAML file, and that becomes your source of truth for shipping out those data. That becomes your source of truth for how do you want to ship out those data. So this gives you a big luxury when you have multiple systems running in multiple locations or something. So you don't need to every time change those data controls. So either you keep this YAML file either in a system parameter store, or either you can keep it in a S3 bucket and invoke that into your application. And the last thing is also one of the main important thing that I'm going to show it to you in the demo as well. So the telemetry or the OpenTelemetry under the hood enriches your whole whole metrics data that is going to ship out. So it would auto-populate like from which environment that you're calling it, from which is the client name that you're calling it. So what sort of a method is being triggered, So, and in AWS also, we have seen like if you are putting a JSON object, from example, in a Lambda to an SQS queue or in an event bridge or something like that. So those sort of chaining support is also given into this OpenTelemetry. And I'm going to show it to you in the demo in some time as well. And lastly, it has a full support of multiple systems. So either you deploy it in Kubernetes, either you deploy it in ECS, either you just adopt that and deploy run the SDKs in Lambdas or something. So it has the support for all the systems that can be hosted. And my favorite part into all of this is like, as I mentioned before, the community is quite active. So if you have any issues, if you go to their GitHub repository, if you open any like issues or any questions, that are pretty frequently answered, and you get support from all part of the world to make sure that you have resolved or a resolution on the problem. Now, just a little bit picture on how does this whole shift that we happen. So, for example, the applications nowadays that are deployed is quite heavy on the SDKs that you incorporate. So either you have this Yaga agent for the traces, either you have some other agents for like OpenCensus agent for the metrics, then you have either Loki or some sort of other different agent for logs. And then what happens is like you do all sort of trade-offs in the monitoring backend. So many customers that we have seen that they use either one tool, but or else we also have seen like customers using multiple tools. For example, they use OpenSearch for checking the logs, and for example, they use Grafana for checking the metrics and other sort of things. But what OpenTelemetry has done, so they have taken up this whole wrapper on top of this. So what you get is like you get an exporter, which is agnostic of whatever like your backend would be. And this exporter, what it does is it consumes all sort of data from the different part of the system. It can be a different signals as well. It can be a metrics. It can be logs. It can be traces. And then you have the option of enriching that. So you have the option of adding your own custom flavor. You add some metadatas, and then you ship it to us. And then if the backend system is capable to handle that format of how the OpenTelemetry is shipping out, then it makes our job or the customer's job easier, because then they have the option of switching the vendors at any point of time. And that's the main agenda of what OpenTelemetry talks about. So it makes your system agnostic of any vendor. Any other third-party tool you don't need to adopt, or your application doesn't need to know where your telemetric data are getting shipped out. And this is just a diagram of how the whole system looks like in a real customer landscape. So you have microservices, which has both a mix and match of auto instrumentation as well. And you can do the manual instrumentation based on the language that you use. And right now, I guess it has support for Python, Java, Node.js, and other languages as well, but these are the three ones that I have used. So it's a pretty decent stable SDKs that can be consumed into your application based on the language that you are writing, and then you can you have the option of shipping it out to any other services. So if your application or if your OpenTelemetry is scalable enough, so you send it to an OpenTelemetry collector, and then you basically ship it to the third-party agent. Or if you are using serverless applications, if you're using Lambda, which is going to be my demo, part of the demo today, so you don't need to have a collector agent. So Lambda automatically has this OpenTelemetry exporter spin up on behalf of you. So it can ship it to different other agents as long as the third party is compliant of the OpenTelemetry framework. But yes, I mean, as you can see, like the OpenTelemetry becomes a source of truth or the foundation in the whole observability, and it can really help you to make your applications run ship out all those telemetric data like signals, like metrics, logs, and traces. And apart from microservices, also you will see here because I have a demo with DocumentDB, which is nothing but a MongoDB or managed MongoDB one. So you also get the support of shipping out the metrics from those ones as well. Now, how do we basically divide the components of OpenTelemetry? So as I said before, like this is a quite re-instrumentation in terms of modernization world implementation. So you need to make sure like your application that you are writing is capable enough, or you need to make your changes in the application. So what we normally recommend being a partner of AWS is try to adopt this OpenTelemetry in a very nascent stage or during the greenfield stage of your project, so that you don't have to go back and again change your applications. So your application has to have adoption of the AWS the OpenTelemetry SDKs, and then you have a collector agent where you spin up the YAML configuration, where you can basically write like, or do you want to ship it in batches? Do you want to ship it all at once? So what would be your monitoring backend? Will it be Prometheus? Will it be Datadog? Will it be Jaeger? Will it be Dynatrace? Or whatever. So that sort of an endpoint or that sort of a configuration that you do in the collector agent. And in the last, you have the monitoring backend. And that is where you basically visualize your data as you make your application observable. You make decisions based on the telemetric data that you showcase in the monitoring backend. So this is how the whole chain of OpenTelemetry is adopted into an application. And I can't emphasize more enough, but yes, this is something that we always go and say to the customers, that if you choose to take this path, do it in the pretty initial stage of your project, so that you don't have to go back and change, and that requires more headache. Now, some of the concepts of OpenTelemetry, or why OpenTelemetry is so much prevalent. So one of the main things that I wanted to highlight here is this context propagation. So in the demo that you can see that it basically chains up your spans. So it basically has sort of a sub traces that you can basically make sure like from which method is calling which method, and and then if it's calling a third-party API, or if it's even calling a database, or whatever, if it's just creating a sort of its own correlated log methods as well. But this is one of the main concept, or this is one of the key player why customers have started adopting this, because you get to see quite a good visualization of the traces, or how you can correlate multiple traces, because you have parent IDs, you have span IDs, and then you have this start time and end time that gets auto-appended into that. Now coming to my demo, or what I'm going to show you. So I'm going to show you how does the serverless pattern works here. As I said before, and many other of my colleagues that have said before, using the serverless patterns, you get to offload some of the maintenance stuff to AWS. And here also you can do the same. So you don't need to adopt some different custom layers if you want to do an auto instrumentation. So you add this OTel or whatever we have the OpenTelemetry as a layer into the Lambda function, and that by default supports, or that basically spins up all the enrichment processor that is required on the back end of the Lambda. And when you ship out the logs, when you ship out the matrix, you will automatically see that what are the different things that got appended and everything. Now coming to my demo part, so I'm going to shift my screen to the Lambda function. So what are the things that we need to do here? So for the first thing that we need to do here is we need to add these environment variables here. So we are telling the Lambda functions or AWS that yes, our application will be OTel compliant. And then where do we keep the collector.yaml or the data config agent? So where do we ship it that? And then what will be our propagators in terms of traces? And then one of the other things that we need to do here is add our layer here. So whatever arch that you're using, either AMD or others or ARM, and then which region that you are using, and then what is the language. So once you populate this thing, that's it. So your application is OTel compliant. You have done the auto instrumentation, and you can see the logs that are coming in. So let me go back to my presentation once again. So my presentation is basically a simple solution construct. So it's nothing, it's just an API gateway. I send some requests from the endpoint. It does a proxy protocol. It sends all the requests in the backend. And then there is a Lambda function where I have divided, like, is it a get method, is it a post method, or is it a delete method? And then if it's a post method, it ships it back to the MongoDB. If it's a get method, it fetches it back from the MongoDB. It's a plain, simple method. There is no logic in the Lambda function. It's just like the verbs. It checks the verbs that are present on the API, and then whatever it sends based on the verb, it either pushes it, or either updates it, or either deletes it. So so this is how my application looks like. So what we have to do here is, like, we have to adopt these SDKs, and these are the same things that you can. I'm gonna put it a little bit more so for you guys to visualize. But yes. So either you are using Lambda, or either you are using Python or Node.js or Java. So you initialize your OpenTelemetry, and then you mention where do you put what you need to put your trace, and that's it. So then if you want to do some manual instrumentation as well, you can write these functions as part of all the startups. You can add some custom attributes that I have added here, like what sort of an event is coming in. If I want to capture that context in the same tracing as well. So those sort of metadata that you can add it on your own. Now I'm gonna spin up I'm gonna fire some REST APIs just to generate some traffic, and then we are going to see how it gets enriched. So I did some get methods, and you can also have some post methods on that. And when I look into the logs, you can see, like, without me writing any sort of additional overhead, I see all these things get appended. Like, what is the start time? What is the end time? So what sort of a trigger that is happening? Which is my user agent? So I am using it from Postman. What is the host name? So these sort of things are automatically appended into my logs, and I get to see all these things. So that is one of the advantage of OpenTelemetry, is like they do all sort of enrichment via under the hood. So you don't have to manually add that. I mean, given the days when I used to work with monolith applications, and before OpenTelemetry, we need to write like console.log or logger.info, or generate those traces. So you see, without anything, you get to add those traces as well. Now, one more important thing that I'm going to highlight here is the tracing part, because you can go to AWS X-Ray here. So X-Ray is nothing but your managed service for showing the traces. And here you can see, like, I have a more clarity of the tracing. So I have a parent ID, I have a span ID, and if you take up those JSONs, if you ship it out to a monitoring backend, and if you do all sort of a triggering based logic, you can easily find, like, okay, which trace is calling which function, or what sort of an application is going on this. So for example, if you see, I have made it like a call a third party, and what it does is, like, it sends it to a random endpoint, and it fetches it to that. So in a single JSON, you not only get the advantage of getting the metrics out, the way that it's the start time, ship time, you also get all these metadatas which can correlate and give you a meaningful data for taking a business decision. But yes, just to point a note here, I have put this in AWS 1. This demo was fully built on AWS native services, but it doesn't mean that it can't go out on any other ones. So as long as your data control is good enough, you can ship it to any other ones. Now for the last part of my design. So this is how we trace the auto instrumentation. If you don't want to get into the hassle of what I showed before of the manual ones, you can just do the turn on the X-ray configuration, Make sure like your IAM roles that is being backed in the Lambda functions has the proper permission to put those data into your X-rays, and that's it. So you can get either Lambda to Lambda invocation, or if you want to put it to any other SQS queues or even bridge. So you're tracing, or in the AWS X-ray console, you get a nice graph of from where it is being called. Is it calling a third-party one? Is it calling a database? And one of the things that I didn't show here is like if you want to see a SQL queries also, error in your queries, that also you can find it in the trace. So your traces are intelligent enough to find like if one of the database call is failing, that gets captured inside that. And that gets shipped out in the trace as well. Now, how do we estimate the cost here? So the first cost is mostly towards the AWS X-ray side, but this is also like taking a huge amount of buffer, because because when you see, like I mentioned here, a sampling rate of 100%, which is like really, really impossible. We don't capture all the requests. We only captures the important ones. So that costs around like $250 per month. And then we have the CloudWatch, which is also under the assumption that I am putting like 1 GB of log volume every day for 30 days, which is also like quite unnatural. You don't put like one GB of log volume, and if somebody is putting it, they're doing it very long. So overall, it costs around 300-ish to just make your system observable. And then, of course, you have a little bit of other cost of setting up the CloudWatch dashboards of whatever metrics that you need to see. But this is something that you can basically target or estimate around implementing the OpenTelemetry framework. Some of the links that I have highlighted here, and just to put the note here, the third one is my own, but that is one is related to ECS one. So if you want to have a OpenTelemetry in AWS with containerized one in a highly available and scalable way, you can reach out to me or check the third blog that I have written here, doing the solution construct. Perfect. Thank you so much for taking the time. But before we move out, anybody has any questions? Because I am really curious to understand if any of you have interest, have adopted OpenTelemetry, or if you have any questions, I'm more than happy to answer. Yes.
Traces, if you're testing your application with OpenTelemetry, are they also like visible in the X-ray? Because if you instrument with the X-ray SDK, you get like visual.
Yep.
So it works the same way?
Yes. Your OpenTel X-ray is also like OpenTelemetry compliant. So in the collector.yaml, if you mention your exporter as X-ray, so it gets published there as well. Any other questions? Nice. Thank you so much.